Hello, everyone, and welcome to this edition of 24 Hours Have Passed Summit Preview 2015. We're excited you could join us today for Melody Zacharias' session, Distributed Replay, Testing with Your Data Your Way. This 24 Hours Have Passed event consists of 24 consecutive live webcasts delivered by expert speakers from the PASS community. Today's session is a sneak preview of just one of the huge lineup of technical sessions that will be presented at the PASS Summit in October this year. All sessions are being recorded and will be available for on-demand replay at www.24hoursofpass.com in 1 week. My name is Vicki Van Dam. I am the Operations and Project Manager for PASS HQ. I have a few quick introductory slides before I hand the reins over to Melody. She will speak for 40 to 45 minutes, and then we'll move on to Q&A where you can ask any questions that you may have. Next slide, please, Melody. If you are having any technical issues, please type a question into the question pane on the GoToWebinar control panel, and we will be here to help. Feel free to answer questions in that Q&A field at any time. That question pane is located on the right-hand side of your screen. Once we get to the Q&A portion of the session, I'll read your questions aloud to Melody, and we'll go through them at that point. Note that there will also be a short evaluation at the end of the session. Your feedback is very important to us, so please do take a moment to complete it. Next slide. I'd like to take a moment to thank our presenting sponsors, Microsoft, Dell Software, and Idera. In addition, I'd like to thank our supporting sponsors for this event, HP, SQL Sentry, and Pyramid Analytics. 24 Hours Have Passed would not be possible without the support of our sponsors, and they are the reason that this event is brought to you free of charge. So please show them some love, tweet them on Twitter, and we appreciate their support. Next slide. I'd like to bring your attention to the upcoming PASS Summit. Taking place in Seattle, Washington from October 27th to 30th, the PASS Summit will feature over nearly 200 sessions with world-class SQL Server experts. Planned and presented by the SQL Server community for the SQL Server community, PASS Summit is single-handedly the largest gathering of SQL Server and BI professionals in the world. With over 5,000 registrants from across the globe, PASS Summit is also a great place to network and meet face-to-face with experts, peers, and MVPs. More importantly, PASS Summit delivers on providing you with the answers to your SQL Server issues, along with the knowledge, strategies, and skills you need to stay ahead of the curve. Right now, you can save $200 by using discount code 24HOP15, and you can optimize your savings by registering before the end of this coming Sunday, September 20th. That's before the next price bump. To find out more, please visit www.passsummit.com. Next slide. Make sure you explore everything PASS has to offer for data professionals. You can join local user groups around the world, virtual chapters, and find free online resources through our Learning Center. You can also read up on the latest community news in the Connector newsletter. For those interested in or working in business analytics, visit www.PASSBA Conference for more information on the PASS Business Analytics Conference or to subscribe to our Insights newsletter. Next slide. And now I'm happy to introduce our speaker of the hour, Melody Zacharias. Melody is a regional mentor for Canada and the leader of the Southern Interior PASS chapter. She has been passionate about SQL Server since version 7.0 and is an enthusiastic volunteer for PASS since 2011. Melody, take it away.
Thanks very much. We're going to talk today, as mentioned, about distributed replay. I appreciate you joining me. For those of you in the Pacific time zone, I realize how early it is and appreciate you getting up so early to attend our session. But we're going to get started right away. Right away here with our agenda. So we're going to talk today about the different aspects of distributed replay and touch on a few tips. But before we even get started on that, why or what is distributed replay itself? Distributed replay is a tool from Microsoft introduced in SQL Server 2012. It is used to test your data or test your situations with your data. So the key to this is you can test absolutely anything that requires almost a before and after. At least that's how I like to think about it. If I want to test how my indexes are performing, I can do this with my own data. It's probably one of the most used, one of the most important ways that we use this tool is with indexing. What I had used it for recently with a client was to test TDE, which is the encryption software for Microsoft, in their database SQL Server. We wanted to know how our specific data, I was working for a client at that time that was a bank, and we were concerned with all of the pulls on our actual hard disk, and that's where the TDE is most expensive in terms of performance. So we wanted to know before and after shot, basically, of our actual data on a day-to-day basis to know what type of performance hit we were going to have when we introduced TDE to our entire system. So we set up TDE running actually in production on an actual production machine, busy day, our main SQL Server for production, and had very little performance impact, first of all, on running the collection of the data. And then I was able to take that data back, run it on a test system using distributed replay to actually test a real life situation. So we were able to do a test that mimicked exactly what would happen in production, so that we were able to give the business, the users, and the management real live data analytics showing that we were not going to have an issue when this product went live. So our agenda today is to talk about why we would use distributed replay, what it is, and how are we going to set it up. There are going to be a couple of tips and tricks in here. Microsoft has done a pretty good job explaining this in books online, as they do most of their things, but quite often, as with other tools, there's a little bit of overlap with some other disciplines or things that maybe in really large organizations would possibly even be done by somebody else. And some of those things aren't covered in books online, so I wanted to cover those today so that you have a full view of how to get this set up. And then I'll show you a couple of diagrams at the end about what it means to have this set up, and then what you can get out of it. Sometimes that's the most important, is what are you going to get in the end, and what's that going to look like? So let's get started on that. Distributed replay is going to give you a production-like workload. It'll give you the opportunity to monitor and evaluate potential performance, upgrade, or functional issues. It's really great for helping with capacity planning. There are some third-party tools out there in the marketplace right now that will help you do this, but often they don't use your actual data. Quite often in situations at different organizations, depending on the type of data you have, it's really important to use your data to simulate a real-life situation. Data that you make up on the fly, sometimes great for Q&A kind of testing, but when you actually want to test performance, there's nothing better than having your actual own data to do this. So then you might say, well, why don't we just use Profiler? Because Profiler and Distributed Replay both capture trace data. The problem with Profile is, particularly with multi-threaded processes, you can run into bottlenecks. With a single computer replay or for OLTP transactions, this multiple connections will cause a bottleneck that will slow down your system, and it actually skews your data results when you're trying to do any analytics or determination of how things are working. So the tool itself can change your results, and that's not what you want to have for excuse me, for detailed testing. So you don't want any throttling, you don't want any bottlenecking, you want to have the most accurate test you can. So you get that with distributed replay. It's truly distributed. You can have multiple computers running concurrent processes. This will make it really excellent for performance testing and capacity planning. Distributed replay will support up to 16 computers. That can be either physical or virtual. It's going to give you your own workload. You're going to be able to test anything from indexes to TDE to hardware or anything software related. But of course, nothing's perfect. No product is perfect. There are some limitations listed here. The features for Profile that are not in distributed replay. And the one that can be, oh, I'm sorry. I missed a slide. So no product is perfect. What you may end up with is these features that are available in Profiler that you're not going to have in distributed replay. If these are some of the things that are important to you when doing your testing, you might want to consider still using Profiler. The one that often gets people is the line-by-line debugging, particularly for developers or when testing software. So what are the parts that make up distributed replay? It's a console tool that requires some setup and configuration. This is one of the things that, in my experience in talking to other people, is what causes people not to use distributed replay. It's sometimes not the most intuitive to set up. So that's one of the main reasons I did this session, is I wanted to show people that if you have all the information, particularly in one spot with this slide deck or from seeing one of my presentations, then if you get more familiar with distributed replay, you're more likely to use it. So let's start by looking at the different parts. These are all the different sections of distributed replay's tool, and we're going to talk about those individually as well as collectively and how they work together. So I love this slide. You've seen it already, you'll see it many times before, but quite often it's much easier to understand what's happening in the process if you have a diagram outlining what's going on, gives you a visual representation of all the different parts of the tool and what's being affected at each individual time. So let's start with the admin tool. This tool is installed as part of the management tools. As I mentioned, it's a feature of SQL Server 2012 and greater. It's still available in 2016. I'm sure it will be for quite some time. It's a console application that initiates, monitors, or cancels operations on the controller. One of the important things to remember about this, as not everybody is up to SQL Server 2012 yet, the nice thing about this tool is that the management tools for SQL Server 2012 can be installed on any server from 2005 and greater. So it doesn't matter if you're still back on 2005 and you want to do some performance tuning or even test your upgrade, you're able to install the tool set itself for the collection of data only on a server as old as 2005. So once you collect that data, though, you have to replay it on an instance of 2012 or greater. But that's not always an issue, because quite often you're going to want to do this in test. So you can spin up a new 2012 server and do your testing that way. But you can still use legacy data to an extent, and as long as that data is on something as new as 2005. So that takes us to our controller. This is a service that coordinates multiple clients. So the next thing that you see downstream is the clients, and this is what controls those. You're going to have one controller and one administration tool per installed environment. I'll elaborate on that a little bit later, but you can only have one of each of these. However, you can have up to 16 clients. So as I mentioned, in our clients, they're going to work together. It's going to be controlled by the controller, and that's what I mean by controlling the clients, is it's going to control the simulated workload on those client servers. And you can have a maximum of 16 of those. They don't have to be physical. You could have physical, virtual, and a mixture of both. The target server, our final server in our stream here, is going to be a SQL Server 2012 instance or higher. And I highly recommend this be your test environment. The whole purpose of distributed replay is to test your data. Test means test. Let's not be doing this in a production environment. Very important. So we've covered what distributed replay is. I showed you a couple of the different parts. I apologize for running through this so quickly. We are short on time, but let's get into some of the nitty-gritty of how this all works. So once we get into the how, we're looking at all of these different pieces, but what do they really do and how do they work together? As a console tool, you may be concerned about the functionality. However, each of these processes has its own XML configuration file that we're able to enable and customize. For ease of explanation, I've diagrammed each of these pieces on separate servers, but the blue box here outlines the services that can be combined on a single server. So you may look at this diagram initially and go, I don't have that many test servers, I don't have that many instances I can use, but each service has its own configuration file, so this will allow you to combine services on one server if need be. So here's the configuration files. The file path at the top there is going to show you where to find these. These are installed when you install the tool. So these are the configurations that you can modify with XML. The level of control that each of these file systems gives us is different with each of them. For the pre-process configuration file, which is located on the admin tool, it allows you only to modify the system session activities that are included and the idle time only. So not a whole lot there. However, when we get to each of the successive items, we're going to have a little bit more control. With our configuration file for our controller, we're going to have logging level options, we're going to have informational options as well. So I did mention that yes, we're going to have to deal with some XML. Not to worry if you're not familiar with XML. It follows a standard pattern. It's going to give you a start and an end tag with your data in the middle. The controller file is the only thing that we can configure with the logging level option. So I've outlined that here to show you how the logging level is inserted in between the two greater than and less than tags. So it's a matter of simply putting in the value that you want to change that right there. Within our client configuration, we can modify the controller file location, the working directory, the result directory, and the logging level. So it's slightly more complex, however, the basic principles still apply. Replay configuration is located on the same server as the admin tool, and it has quite a few configurable options. It's used by the admin tool to control all the actions of the coordinated replay within the clients. This is why we have so many additional options. So all of these options are available. I'm not going to go through each one individually. There's quite a few there, but it gives you an idea of the magnitude of things that you can change on each of these target clients, and each of those clients is going to have one of these files, so you can change each one to be different if you choose to. It's simpler, obviously, to keep them same, particularly if you have many servers, but each of them can be individually updated and coordinated. The configuration files are engaged and validated when the related service starts on each server that has a service installed. So the pre-process and replay configuration files are not loaded, but used by the controller at a particular stage in the replay. Here's an example of how to restart each of these services. And just to reiterate, the configuration files are engaged and validated, which means they're really reloaded every time a related service starts. So on the controller, if you've changed something in your XML file, you're going to want to restart that service on the controller. Same for every client configuration. So now the rest of the story. All of that information you can find in books online, not a problem. Fairly easy to follow. There's a couple of examples. It's really great. But if any of you are from Canada, you may remember a host on the radio program, The Rest of the Story. It was hosted by Paul Harvey. And what he would do is tell you historical, what appeared to be stories at the time, but at the very end, he would let you know what the little known or forgotten facts were. Often it was somebody who later in life became a really important person and how this may have changed their path in life. This may not be quite as dramatic. However, this is essentially the end of the story if we were looking at TechNet, MSDN, books online. But what we forget as DBAs or developers sometimes is that there's system security issues and servers that talk to each other and things that are sometimes considered, particularly in larger organizations, outside of our job description or expertise level. So if you were to do just what we had talked about and nothing more, we'd probably end up with an error at this point and unable to run some of the processes we'd like to run. So the first file there is the location of where the error log is, because of course we're always going to check the log, make sure that we set everything up fine. And this access denied error is very common. It is descriptive of a generic issue as opposed to telling you exactly what you're denied access to. The key here is you're denied, this specific hexadecimal code means that you're denied access to the DCOM. So that's Microsoft's Distributed Component Object Model. And I know in many positions I've had before, this would not have fallen in my realm. I probably wouldn't have been aware of it and may not have been able to solve this issue on my own. It's important to know and to help out either those on your team or in other departments. Great way to get in with your sysadmin, get on their good side, because it's always nice when you come to somebody not with just an issue but with a resolution. So how would we fix this? If you're not familiar with the Distributed Component Object Model, it's Microsoft's component distributed networked computers used for communication of software components. So this is a software component according to Microsoft. It's going to need to communicate across network computers. We need to set this up and give it permission. So that's going to take us into our first demo. So to fix this access error, we need to go to component services. You may or may not have access to this at your installation, but you'll know who does and be able to get that help. If like me, you don't use component services often, it's handy to remember that you can access it from the start menu, choosing run, and then type DCOMCNFG. That's going to take you to this screen that we see here. Click on the distributed replay controller, and it's going to open up, and we're going to open up the properties right here, and we're going to select the security tab. Here we can grant our service account the proper access permissions. So we want to edit, launch and activation permissions. We're going to grant our SQL Service domain user account, whatever that happens to be. It may be the default network services, it may be something set up completely different for your AD environment, but you want to make sure that they have both local and remote access. So we want to launch and activate the permissions to apply them the next time the application is started on the server. So also note that this is on the client server. This process will need to be done on each client that you're running, not just one. So if you have all 16 client computers that you're able to use for distributed replay, this is going to be a lot of changes that need to be made. We're going to add the domain, the SQL Service domain user account to the distributed COM users group as well. This is a local group and will also need to be done on each individual client. So first of all, we're going to give it permissions. We're going to add it then to the proper group. All right. So once we've done that, as I mentioned before, we're going to have to restart the services, whether on all the clients. If we haven't made any changes to the controller, we don't need to do that. However, every single client that you've updated those changes on will need to be restarted. This is going to reload our configuration files that we had talked about earlier. Once the configuration files are restarted, you're likely going to see one of these two messages. If you get the first one, excellent, great, you're ready to move on. Again, I've put the log file location at the top of the screen. However, if you get the second one, this is, again, obvious, right? Of course not. It's going to say that you failed to connect to a controller this time as opposed to access denied. This one is a firewall issue. So this time, we're going to go into our second demo and take a look at the firewall. So in Server Manager on our client again, and again, this is going to have to be done on every client that you're using. You're going to need to open the Windows Firewall with Advanced Security. You're going to click Inbound Rules. You're going to right-click and select New Rule to open the New Rule wizard, and that'll walk us through the process. Again, this may or may not be something that you're able to do in your organization, but when you see that error, at least you'll know who to ask and explain to them that you need a firewall opened up for your distributed replay. The rule that we're going to set up is going to be a program because we want to let distributed replay through the firewall to ensure a connection can be made from the client to the controller. We're going to select this program path. We're going to browse to the distributed replay client EXE. So I've got the tail half of that path so that it's easier for you to find there in the location of, of the window. For security reasons, we want to be really specific to distributed replay and to the distributed replay client. We don't want to have any security issues with this, so keeping it very specific will keep your network admins very happy. We're going to allow the connection and click Next. We want to limit the security issues that we may have by limiting it to our domain only. There's no reason why anything on distributed replay should be happening outside of your domain. And it's always nice to give it a meaningful name. Allowing the distributed replay client is pretty obvious. Then we're going to click Finalize. And again, restart our services. Always restarting our services. This is something that you're going to repeat over and over and over again until you have your process flowing very nicely. So this may seem like a lot of steps. We're going through a lot of configuration and we're having to restart services all the time. And that's true. However, once you've done this in your environment, you only need to do it once. So once we get it all set up, it's going to be done. You're going to be able to do your testing, and every test after that is going to be much simpler and take a lot less time. So this time when we go to verify our logs, we're going to see something more along this line. We're going to get a message specifically that says registered with controller. This will mean that the controller was able to register with the client and you're going to be able to run your test. So finally, with all of our servers, our files, and our permissions configured, we're actually ready to get on to doing some work. But the next step after this is collection. So we've got it all set up. Let's get some data. Collection is the process of gathering and preparing the data that we want to use. It takes place on both the client and the controller, depending on the stage that you're at in the process. So this section here defines the collection stage. We're going to start with the trace file. The process to create a trace file may be familiar with you if you've used Profiler before. However, there's a few specifics that we need to be aware of. That's going to take us into our third demo. So when we open Profiler Trace on the controller from the SQL Server 2012 Performance Tools, there is a template that will allow us to ensure that we have all the pieces needed to actually do the replay. So regardless of the version of the target server, you want you want to ensure, because this could be done on a 2005 machine, so you want to make sure that you have installed and are using the SQL Server 2012 profiler to ensure that this template is available. So if you are looking at, say, a profiler for 2005, this T-SQL replay template won't be available. They are T-SQL replay, it's going to be backwards compatible, but the only way that you're going to be able to run this on your 2012 machine is to make sure that you use the proper template. The second tab shows you the reason for that. The second tab has the list of default properties required for distributed replay to function. You can add to that, but I don't recommend that you remove anything. In the references at the end of this slide deck, you can get some more details of the events and collection items. But it's highly recommended, at least the first few times, that you start with the template default and then modify your trace by adding additional items based on your testing requirements. Once you have the trace run on your server, it's still not ready for replay. There's a process called the preprocess, and this step will produce the remaining files needed to do the replay. So this trace file is going to go through the preprocess selection, and that is both pieces part of the admin tool, and it prepares the trace file to actually be run. The command to get this preprocess launched from the admin tool has a few minimal required parameters. Those are here in blue. So our different items are going to require, first of all, our path name of the trace file. So I being the input trace file. The thing to note here is that this trace file cannot be a UNC path. So if the admin tool is on a different computer than the controller, you'll have to move the trace file so it's on the local server. Our next item is the location of the working directory, which also must be local and fully qualified. This is where the dispatch file is stored. Then our next item is the server name of the controller. The default will be the local machine, but if your controller is on a different machine, you're going to need to change that. An alternate configuration file if you want to change some filtering or max idle time. Our default is what I had listed earlier, is our drreplay.exe.preprocess.config, but as I mentioned, that can be changed if you don't want to use your default values, and that's just the location of that file. And then finally, our default interval. The default is to display status messages every 30 seconds, and they will come to the screen unless you have set up something to log it to a file. So that might be one of the items that you would be interested in changing. Then the last step in the replay itself will be the actual synchronization and replay of your data. It looks like a simple step, but this is also where a lot of the additional action is happening. If you're testing with scripts, jobs, third-party monitoring tools, all sorts of items, this is where everything comes together. It's going to mesh. This is where the meat and potatoes, so to speak, of your testing is going to happen. Notice how the launch and synchronization happens on the controller. This is so that it can synchronize all of those different clients. I have just one client shown here just to make the diagram a little simpler, easier to see what's going on. But the controller is actually synchronizing the run of the replay on every client at the same time. This is what makes distributed replay so powerful. This can be one machine, this can be 16 machines, and they're all going to be synchronized together. The command to run the replay is launched from the admin tool and has a few required parameters here. We're going to look at the working directory, which must be a local qualified name, where intermediate files are going to be stored. We're going to look, the second item, our clients, is going to list the names of the computers that should participate in the replay. IP addresses are not allowed here. So when you're talking about clients, all clients listed also must be registered with the controller. So earlier we had talked about restarting those services. That's what happens when you restart that service. That client is going to register with the controller, make sure the two can talk to each other, and those are the clients that you're going to list there. So you're going to be looking for actual server names, not IP addresses. O here indicates our output file. As I had mentioned, the default is for everything to be written to the screen. If you're looking for an output file from your testing, you're going to want to use this. You're going to put, this is what is also going to be your result directory, the element of the configuration file, and what controls that is going to be the same as your drreplay client.xml. So those two should be the same. The server name of the controller is going to default to be your local server name. Your target server specified has to be a fully qualified format name, so you're going to want server name / instance. Localhost is not acceptable for that, so your target, that's your target server again. Localhost is not acceptable. It's important to have the actual server name / instance name. So it's important to remember here that if you had not specified the option of the configuration file, it definitely must be declared here. Otherwise, it would be in the replay options of the DR replay configuration. Then for an alternate configuration file, it can be stored in a different location. The default for the DR replay configuration is drreplay.exe.preprocess.config. And finally, F being our status interval is our default interval. The default is to display status messages every 30 seconds, or if you've changed your file location, it'll be where it writes to your log at what interval. So if during the replay command you specified an output file, the results of the replay will be stored on each client participating in the replay. So each client is going to have its own log file in the directory specified from that command. Otherwise, it's going to return the results to the screen where the command was initiated. So each command for each individual client. So uses. What are the different uses of distributed replay? We talked about this at the beginning, but now that we've got it all set up, what are we going to do with it? So there are a lot of uses. TDE, obviously one of my favorites because I had recently done that with a client and they were just thrilled. They loved the fact that as a Microsoft product, not a third-party product, it was very easy to get approval from management to have the tools, the SQL Server 2012 tools installed in their production environment. We didn't have to go through committees to have that approved like you would for a third-party product quite often, because it was already a Microsoft product. Even though they weren't running 2012 in their production environment, it was an easy approval to get it in and to actually collect our data. So once you've got the data, though, you can do any of these other items. You can tune indexes, you can look at hardware upgrades, software upgrades. And one of my favorite things of that is once you're doing that testing, you can continue to do that testing. You can do different, you could do index testing today, you can do a system software upgrade test tomorrow. And out of that, as data professionals, we're used to dealing with large amounts of data. So what do we do with all of that data that we get back? Depending on what we're collecting, we can have all sorts of different analytics that we create from that. So our results are going to be things that are tangible to management, allow our clients to make decisions based on analytics. Everybody likes a picture, so graphs and tables are always popular. So when I did my TDE, this is the graph from my read latency. And as you can see, at around 7:23 p.m., we had a little bit of spike in our read latency. So what this is going to show me is that instead of having something cached in memory, my process had to go to disk to get that. Keep in mind, as I had mentioned earlier, I was testing my TDE encryption. So with TDE encryption, you're encrypted on disk. When you read that into memory, it has to decrypt it. So this spike in my latency is going to be that decryption. But for the most part, over that time period of approximately 30 minutes, we only saw one spike. So that gives us an idea of actually how much memory or how much data we're actually storing in memory. So that was quite reassuring to my client to note that we only had this one spike, and it wasn't a huge spike. As you can see, we still only hit 25% CPU. This is excellent. And those are the types of things that your management and decision makers are going to want to see. So I apologize for having to run through this really fast, but we had a short period of time. However, you will see more distributed replay at Past Summit 2015. I will have some more tips. We're going to solve a few more common issues. And I'm going to produce some of those scripts for monitoring. So this graph, you're going to ask me, I'm sure in the questions shortly, how do I get this graph? What do I monitor? How do I monitor it? All of those things we're going to go over at Summit. Unfortunately, we were unable to have the time to cover that already. As you can tell, I'm starting to lose my voice already from trying to talk so quickly and get through all of this material. It is a lot, but it will be available to you within a week. And then always, I'd be happy to see you at Past Summit. So all of these we can cover then, or you can send me an email. Here are some of the resources that I had mentioned earlier, some of the parameters, my blog, and of course my email address. If you ever have any questions, I'm happy to answer those, even offline if you, because quite often what I've found with other people is it all makes sense now, they go back to their environment and something slightly different. So you can always email me, check out my blog for some information on distributed replay as well. So I'll pass it over to our monitor for any questions.
Thank you very much, Melody. We do have a couple of questions that just have come flying in there. Does the number of replay clients need to be equal to the number of clients in the real environment?
No, that's one of the great things. If you are going to add additional clients, you can test it in your environment before you do that in your production environment.
Great, thank you. So here's another question. I may be wrong, but Microsoft is going to depreciate tracing or SQL Profiler in favor of extended events in later versions of SQL Server. How is this fact correlated with distributed replay functionality? Is there going to be any replacement for distributed replay?
I've not been privy to that information from Microsoft. I doubt that even if Profiler as a service is removed from general use within SQL Server, the concept and the engine aspect of trace files will still be there. So trace files will continue to be used by distributed replay. It being a newer product, I would be surprised if Microsoft would get rid of the trace files.
Okay. Can you use distributed replay with extended events?
At the moment, I am not aware of any way to use the distributed replay with extended events.
Okay, Dennis is wondering, is it possible to replay in-memory OLTP, aka hackathon, workload with the distributed replay?
I'm not that familiar with hackathon, but I do not see why not. Any data that you can collect with a trace file can be replayed.
Perfect. And I'm not quite sure I understand what Esther is asking, but what she's written is how to load your log data. Or how do you load your log data, perhaps? Does that make sense?
The log data that comes from the clients after the fact, that's just a basic log file. What I had mentioned at the very end when I was talking about the graph itself, quite often that's analytics that you collect as the trace is running. So I had mentioned that when you're replaying your trace files, there are third-party products that you can run as you're replaying. There's also ones that you can create yourself. So the way I created that graph was I had a T-SQL script, for lack of a better explanation, that was collecting data during the replay itself. So I had scheduled it to run every every 2 minutes for 30 seconds, and I would collect my own data and put it into a table. So those are some of the things that I'll also be covering at PASS when I have a little bit more time.
Excellent. And Matt is wondering, is this enterprise only?
No, that is the best part. It's not. When I did my TDE, it was all done on standard version.
Great. Did anyone else have any other questions? That's the last one that I have in the queue right now. Oh, we've just got one more from Dennis. Will inequality of replay clients and real clients skew the test results?
Yes and no. It depends on what you're testing. So if you're testing hardware, I guess if you're testing software, you want to get as close to what you're going to be running it on as possible. So if your servers are of different classes, or the storage even of where your data is, so if your database in test is running on tier 3 storage and your production database is a tier 1 storage, obviously your testing is going to be slower. That's no different than any other testing that you do, so I would say it's similar to real world testing at the moment. It doesn't skew it in any way.
Excellent. Well, if you have enjoyed this session by Melody, please, you know that you can catch her at the PASS Summit this year for her session, Distributed Replay Testing with your data your way. Melody, do you mind moving me on to the next slide? Sorry, one more. Coming up next, we have Alan Hurt, What's New for High Availability in SQL Server 2016 and Windows Server 2016. That session will be kicking off in about 10 minutes. Thank you all for joining us, and thank you, Melody, for taking the time to give us this training today.
You're welcome. Have a great day.